participating and presenting. The question was, what should I talk about? And I figured there'd be plenty of people talking about solutions, so I said, let me talk about the problem. And specifically, our example, my example of what we experienced, what we went through, what we learned, where we saw the pitfalls and challenges. So Dick covered half my slides, so it'll take me less time to cover the rest of them now. So quick, Ingersoll Rand. Ingersoll Rand's about a $12, $13 billion company, mostly in the industrial space. Various brands, one of them is the laser button here. So Train and Thermo King in the HVAC system, both for commercial and residential buildings, and Thermo King for mobile refrigeration for trucks and marine containers. And then on the industrial side, the Ingersoll Rand brand, which covers compressors, power tools, fluid pumps, and then club car. And on the climate side, like I said, you've got the chillers, you've got the mobile refrigeration, the home, and then Nexia is their connected home product that's made. So various flavors and various levels of connected products that exist in Ingersoll Rand today. Different levels of maturity. Train systems in generation 4 right now for the building automation systems. Residential Nexia was launched a year or so ago. Thermo King has their own product that monitors trucks and marine containers. Obviously very critical, because as they go through long distances, they need to know that everything's working right so that the food doesn't get spoiled, right? And especially nowadays, you keep hearing about contamination and bacterial infection in foods and stuff. This becomes more and more critical to ensure that we provide the comfortable, sustainable, and a safe environment for our products which are used by our customers. So that's our motto, and that's the credo that we live by. Is everybody else getting an echo, or is it just me? Okay. So the compressed air portfolio, the compressors, that's the core product, and then, but of course, it doesn't work by itself, so it typically gets into a system. This is the solution that we provide. Can have multiple compressors, storage tanks, other controllers, and then ultimately what the companies care for is what happens at the point of use. So the point of generation, which is the compressor, yeah, you need that, but the company needs to know that, hey, am I getting the right pressure, right flow at the point of use where they want to really use the air, right? So we start taking a look at that, and we say smart connected products. Like I said, various flavors have existed for a while. So you have the smart product, and I'm using Michael Porter's definition of a smart product. It has got 3 elements: a physical component, a smart component, and a connected component, right? So you have the smart product. A smart product has got machine sensing, which is, I was trying to think of an example of a product which does not have some information about itself. Question is, where is it available? Typically, definitely locally available, maybe connected through a LAN or something where you might have the machine information as well as some other system information. And then you have a connected product, so you have a little bit more of an interaction with the ecosystem. And then you take a set of systems, and then you have a smart connected system where it goes beyond just the product side of things to the overall system and the deployment and the delivery and anything else that might be critical for the end customer, end user, what they want. So for example, for air, a big requirement across the board is clean air. You don't want contaminants in the air, whether it's particulate or moisture or any number of things, right? The bottle blowing example, for example, factories, they want clean air. Medical applications, when they use it, you want clean air. So I might be generating really clean air at the compressor level, but that air is traveling through all kinds of other stuff before it actually gets used. So then me as a solution provider, I have to be able to ensure that not only am I generating air, but at the end of the day, I'm delivering that same kind of clean air. So this then drives a lot of the challenges that we have to resolve. Second, as with a lot of equipment manufacturers, the equipment leaves the factory, it goes to the customer sites. You may or may not have visibility of that equipment anymore, right? So in some cases, well, you'll get visibility when there's a problem and you get a call, come and fix that stuff that's broken, right? So obviously the advantages of having it connected enables that visibility, enables us to be proactive, enables us to be provide some better real-time operations, enhance service capability, and all of the usual things that people talk about. So we'll talk about that some more. So I got this slide. There's a paper that was presented a year or so ago in Vienna, and I just like the graphic. So the real value of the connectivity really starts coming after the connectivity, right? I mean, up to that point, you have got, okay, I've got some stuff, it's connected, it's enabled, I've got a controller on it, I can extract information. Well, what do I do with it? And then now you start going up a value curve, which gives you an increasing maturity of the offering and an increased value to the end customer. And you can just monitor it, you can control it, you can make it optimized, you can make it more autonomous in its operation, and all the way up to where you have a complete complete ecosystem that's cross-optimized across all the different players and entities and operating conditions. Okay, perfect. So we can do lots of stuff with a connected system. If I dig in a little bit deeper to okay, what does that mean? I can optimize it. I can make it more autonomous. So what does it mean? Where do we start, right? So the typical starting point is, okay, I can look at it. It's more transactional. I can look at the data. I can get some better visualization. I can start looking at patterns. It's the obvious thing that you can do with data, right? Once you do that, you can start looking at, hey, this data is telling me something. Diagnostics is the other obvious, sort of almost the low-hanging fruit of what you can do with the data. Business intelligence, everybody wants to know, what can I do from a business perspective? Great, that's also fairly simple application, if you will. Now you start going into being able to forecast and optimize the system, and then you start going even beyond that to where you are gathering information not from the data coming out of your system, but what people are saying about your system. TripAdvisor, right? Great, this place is great, I love the place, right? You go, you like the stuff, right? So they say the product is great, you can pull that information out into converting that into useful information for whatever you want to do with it. So you start going from transactional to strategic in how you look at it. Today we talked about cognitive computing. You talked about, I like the one slide that the gentleman from Duke had. You go from hindsight to insight to foresight, right? So you go from being reactive to not just proactive, but you go into minority report trend, right? It might happen, so you fix it. So what you can do once you have the data is limited only by the capabilities of your enabling technologies and your imagination. This is the way it comes out, right? Great, you have that, you look at this, so now take a look at how do we actually go about doing this. So far when we had started on this path and we said, okay, we need to improve our what we do with the data, we need to look at how we improve the ability to use the data to generate value and do all these fun things that everybody talks about. We take a look at what do we have. Ingersoll Rand is a 140-year-old mechanical products company. So a mechanical products company with increasing electronics. If you start looking at it, the electronics in this company started happening only over the last 10 years. So before that, electronics was maybe electro-pneumatic. Before that was maybe electromechanical, right? So you have these discussions, and I'm sure other people have had similar experiences. If I can't see it, it's no good. I can't see an electron moving. I can't see this thing that you're talking about happening through the controller. I don't see things clicking and clacking. Something's not working right. So the transition in thought process to how do you leverage what an electronics enabled system can do. Now you take that almost the whole generational leap forward to say that it's not even an electronics problem. Now you're talking about a software problem, which when you think about it is even more esoteric than electrons moving. So you've gone from mechanical stuff moving to electrons moving to zeros and ones, and you're expecting someone to understand what that could mean. So the change in thought process, the change in mindset, the understanding of the appreciation of what this could do actually is a fairly big shift in thinking when you consider a traditional company like Ingersoll Rand to have to embrace this way of doing things. Right? So we started looking at this. I said, okay, we're going to get into the IoT field. We're going to start doing this connected products, and we're going to improve our connectivity of our product. So the first thing was, what does that mean? Okay, I have a product, right? I'm going to get data. These are my things. I'm going to collect the data. I've got edge devices. I'm going to do something over there. Next, the data has to be sent. Whether it's wired, wireless, cellular, doesn't matter. The data has to be sent. The data has to be sent somewhere where you can do stuff with it. So whether you have your operation center or just a server sitting under your desk, it doesn't matter, right? So somewhere, right, what is the cloud, right? Cloud is a server in somebody else's property. But you do stuff. Once you do stuff, the list below I left it up because we came up with all these cool things that we could do, right? But when you think about it, what is it? You're getting insights. Maybe you can create differentiated offerings. Maybe you can enhance the service, right? All of the things that are possible at the end of the day. So you gather the information, you send the information, you do something with the data, and then you extract value from those things in different forms. Okay. So question is, what do you want to do? We want to do all of this stuff. Okay, what do we have? And I go on the net and try to find out what's the picture look like, what's the landscape, and this is what I come up with. This gentleman, Matt Turk of First Mark, he came up with this. It's published in, and I can't read it in yellow, but there's a SlideShare. You can go on slideshare.net and you can find this. And it was like, this is jaw-dropping, mouth-opening. Okay, now what? Right? Who are all these people? What do I know about them? How do I figure out what's the best option to use? And it just becomes completely, potentially overwhelming. So I'm an electrical guy. Okay, I can figure something out. But if someone who does not have the background to try to evaluate this is pretty intimidating. But this is the landscape. This design solution space for all the people who said we can do this for you, and we have this product that you can use in the IoT space, and all the different building blocks that have to be sorted out, and all the technologies that have to be evaluated. That's a pretty big challenge for anyone who's entering into this field to figure out which path do you take. How do you go from down below and work through this to come up to somewhere where you need to be? Okay, that's the landscape. What do we want them to do? What does the solution space look like? It's a little bit more technical. You look at the architecture. Here are your things. All your different pieces of hardware, your hardware components, you've got sensors, communication hardware, actuator, processor, your operating systems, whatever other things you can think of. What is your data protocols? Whether you're short range, long range, wired, wireless, network protocols, your session protocols, you want to use MQTT, you want to use something else. Then you've got your system hardware, and then your entire IoT platform space that you have to figure out, right? So even if as a consumer of IoT, even if I'm not the one doing the work, even if I'm not the one trying to build up that capability internally, for me to even have half a chance of having an intelligent conversation with a potential supplier, I still need to be able to understand what does this mean. So when you start trying to design, you're trying to develop a solution, you have to be able to build up some basic degree of knowledge. And the challenge that you have is if you don't have a pool of people or you don't have a team, it's hard to find one person who can be an expert in all of these areas to say that, okay, somebody comes and says, I can do this for you. What are you asking them to do? How do you know that they're giving you the right stuff? Right? What conversation are you going to have to say that, yep, this makes sense? So this becomes a huge challenge. Now you throw on top of that security. And people talk about cybersecurity. Cybersecurity is like, I don't know, it's a multi-tentacled organization, an organism in the room, right? So all the different areas of from your device itself, your users, your end users, your data storage, your data security, all of it has to be mapped out and planned for. So there's several discussions. You have the cybersecurity that's your traditional web-based, IT-based, then you have your cybersecurity that goes into your actual control systems, right? There's a conversation earlier that talked about those two are fundamentally different, right? Compressor, for example, somebody overrides the safety limits on my pressure, can come in and say that, nope, I'm going to let it go rise beyond my safety limits. Well, you just had created a dangerous situation, right? So one may not think about compressors as being a potentially hazardous element, but it can be made. If someone with malicious intent wants to come in and somehow override it, and now all of a sudden you've just created a potentially dangerous component in a factory. So you get into all this stuff. So we look at all this, we look at all of this stuff and says, okay, I have to get the data from the things and how do I get that data is critical. So the making it intelligent to be able to help decide what data needs to come out starts becoming more and more crucial. Else, you'll have a ton of data and not know what to do with it. What are you looking at? I mean, that's unfortunately has been a real situation. We collected a ton of data. There's days and days and days worth of data at seconds interval, and then you start looking at it going like, okay, I see a whole bunch of points, right? But I don't know what I'm looking at. So when it then comes down to it, if you start looking at it, I'm trying to simplify this for myself. What is it that I really want to solve? So the first thing that I want to solve is I need to get relevant data. Before I can do anything, I need to be able to define what is relevant, what do I really need to get, right? Typically you say, okay, I captured the data, I stored the data, I analyzed the data, great. But now all of a sudden the data is coming from devices. So do I want everything? What rate do I want it? How quickly do I want it? What frequency? What kind of data? Which of the devices are critical? So you have to figure all that out, and the best place to manage it is at the edge. Now, people can argue, why don't you just dump all the data to the cloud and manage it over there? That's a school of thought too. If you have a wired connection, less of a problem, right? Bandwidth is less of a problem, cost is not as big a problem. You want to transmit the same data through cellular, and I'll talk about why I'm saying this in a minute. Then all of a sudden, the amount of data that you're transferring from your devices to your cloud becomes very critical, because otherwise you're paying for the cost of transmission and managing all that data through the transmission, securing the data through the transmission. All of it suddenly starts becoming a pretty big challenge. Once you do that, these two things are almost the same. So site connectivity becomes really critical. And site connectivity becomes a big word at this point. And then, like I mentioned, identifying and extracting the relevant data is crucial. My slide got swapped, so I'll come to this slide in a second. Why is site connectivity critical? This is my product, but this product goes into something like this, right? So if I have a product, especially when I have a legacy system, I've got a second problem. This may be 10 years old, this may be 20 years old, this may be 1 year old, this may be what's coming out in the future. So I've got all kinds of vintages. I mentioned a while ago the journey of controls, right? Electro-pneumatic, electromechanical. You go back further, you probably even find electro-hydraulic, and then your electronic, right? It's actually pretty typical when we go to a lot of our customer sites that they'll have all of these present in the floor. So you have to be able to adapt and extract data from each one of those different variants of products that are out there, right? So site connectivity is hugely critical. 2, I can't go in and run wires. Customers don't like it, the system gets down for long periods of time, there may not be good mechanisms or routes that I can run these wires through. So running wires is not always conducive. There probably isn't a land drop in most of these places. Cellular reception may be a problem. So when you go in there, you can have a solution that says, yep, I've got cellular, I don't need to worry about wiring. If it's one problem, you go in there and you've got no signal because it's in the basement of some building surrounded by 2 feet concrete walls. Real problem, right? So now you're running a antenna wire that goes 10 feet out to the window so you can get some cellular connection. But each system becomes different, each site is different, and you have to be able to prepare and address each of those sites, right? So site connectivity, designing your system to be flexible enough to be able to address what you might run into becomes critical. My technicians are mechanical minded. How do I give them a system that they don't have to worry too much about how to set it up? That it's instructed clearly enough, it's pretty straightforward for them to go in, they know exactly what they need to do depending on what they run into. It's all of these things suddenly start to become part of your design criteria. So I'll take a quick step back and I'll move forward. Oops, not this step back. Wrong step back. This back. So we had already talked about you have the physical devices, you need to make the connectivity, the edge computing, so all of these 7 devices. The reason I pulled this out was when you look at all of these elements that have to be addressed, and this week we have heard a lot about it have to be open, they have to be interoperable, they have to be flexible to both configure and deploy. So all of a sudden in a legacy system in particular, the deployment becomes as big a problem as the design. And you have to design your deployment practice into the into your thought process. Otherwise, you have a great system, but you go to deploy it, and you have to go do as much effort each time. Second thing becomes is that it's no longer just a mechanical product or just an electrical product or even an electromechanical product. All of a sudden, it's a full spectrum of skills and technologies across electrical, mechanical, IT, software, physical service capabilities, deployment, the whole 9 yards. Everything has to come together in a nice mashup. So, other challenges. People say IT, a lot of IT functions, but the IT cloud is not the same as the IoT cloud. Right? An IT cloud, the traditional IT cloud is nice and structured. You've got some good process and structure in place, a lot more maturity, and then here you have, if I use the old Indian term, fish market. It's chaos, right? So, and this is changing. This is changing all day long. The insights are changing. The use patterns are changing. So traditional IT doesn't directly apply, and in fact, most of the traditional IT folks we run into, they'll support us. You go first. I'm right behind you. So this starts falling into a class of products what I've been calling engineering developed and IT deployed, as opposed to engineering developed and operations or manufacturing deployed. And so the IT role becomes completely different in many ways to the traditional role that IT has to perform in most organizations. Global data management. We are a global company. These products have to be deployed everywhere, right? So you got each region has its own requirements. If you start talking about cellular or satellite connectivity, 3G, there's a different flavor of 3G in each region. How do you manage that? You want to take one size fits all. It's not the best cost or performance player. So all of a sudden you have to manage these SIMs that have to go into the right product for the right location. You put a European SIM, send it to China, it's not going to work. You've got a pissed off customer on your hands, right? and vice versa. So the logistics suddenly becomes critical. How do you define what that needs are? What is the process? How do you ensure that you're not going to have a problem, right? Whether you do it in the factory, you do it in the field, you do it on the site, each one presents its own set of challenges in terms of your design elements that you have to put in place to ensure that it goes smoothly, right? Data assurance and security, that's the other big one. You guys know that they repealed the safe harbor laws, right, which allowed European data to be stored on servers on the US soil, right? Now you can't. They don't have a resolution yet, although there was some email that I saw last week that says they're working towards a new resolution. But what is the new resolution? We think we tend to forget, right? Europe is full of different countries. Each country might want its own data center. So it's like, nope, I'm not going to let you take the data from France to Germany. So now you set up a center in France, you set up a center in Germany. Don't know yet. Envisioning what could be a potential challenge for deployment if you can't move the data to more convenient locations that you need, right? And then certainly not the least, global product deployment. I just talked about this. You create a system, you make it such that it's easy to install in the field, you make it something that the service technicians don't have to do a lot of work to get it activated. You literally want it to be able to call home as soon as it powers up, says, yep, I'm at this customer site, this is the serial number of the compressor that I'm connected to, and the system knows exactly where it is and what it needs to do, and great, right? But the more simpler you want to make it, the more work it takes, right? It takes a genius to make things simple. Somebody used to have it in their email signature tagline, right? And it's very true. And you know the other part, right? You try to make it foolproof, and along comes a better fool, right? So, and so the last bit then is this. So especially when you think about in terms of brownfield applications, all of these things suddenly start becoming a project in its own right, that you have to have the tools, the solutions to ensure that whoever goes out to the field has everything that they need to easily do this. Because the last thing you want is to go to a customer site and look like a fool because it's not working, you're not doing it, you can't call home because the guy's not there to answer your questions. All right. So what does it mean? And I know I'm running over, somebody, the hook will come out in a minute and yank me. But every aspect of design changes. Your product starts becoming part of an ecosystem versus standalone. Your design principles go from your traditional kind of almost single-threaded this thing to more of an interdisciplinary. The design cycles have to become short. You can't. Yesterday, the Renault F1 guy talked about 2-week full-blown design cycles, 220 software releases in a year. So that's every 50 major releases, and 4 times they get to fix each release, right? Apparently, so we don't get that luxury. If it goes out there, something's wrong in the field, you get yelled at. So your cycles change, your functionalities suddenly start going across the board. Do you put all your functionalities in a central controller? Do you distribute it across multiple things? Even if you start looking at distributed sensors, right? Do you just have an aggregator that collects all of the stuff, or do you put intelligence on each sensor node? Right? Your sensor mesh network, how intelligent do you want to distribute the capabilities on the sensors, right? Connectivity, it's required. It's not a choice anymore. Data, it's core. I mean, there's no point doing it if you don't care about the data. Security is absolutely critical for the entire system, and of course, your business models change. Right? The last bit here, same basic this thing. We start looking at it. You've got open versus closed. I think pretty much everybody agrees it has to be an open ecosystem. You can't do it closed. Since you won't have the core competency and skills in one location, and even if you partner with someone, chances are that there will be multiple people that you're partnering with. Co-development becomes critical. Interoperability is the word of the day. You can't, I don't think you can really start thinking any other way. Security has to be at the full ecosystem level, so you can't leave any one weak point. Everybody knows the target hack came in through the HVAC system. Right now, which genius put the HVAC system on the point of sale system? That's a different question, but things that you wouldn't think about. Data has to be scalable. The data management has to be nimble. You start off with 100 connected devices, you're going to go to 1,000. You have to have that capability of ramping up that quickly. Connectivity, like I said, this is core, right? Site connectivity is core. Your gateway device selection is critical. Your technology choice is critical. It has to be adaptable and changeable, because chances are 12 months from now there'll be completely something different that's out in the market. And cost, of course, becomes critical. If I have $1 million asset, I can put a $1,000 connectivity device on it. If I have a $10,000 asset, not so much. My product marketing people will smack me upside the head to even suggest it, right? Functionalities, like I said, you've got distributed. You almost have to consider with a degree of seriousness that you need some edge and core computing capability. You can't put all the computing capability in one location. Design cycle needs to be agile. No real question about it. It's a cross-connected, cross-functional DevOps type application, because it's not just throw it over the wall anymore. It has to work together right off the bat. And like I said, the design principles are essentially multidisciplinary. And at the end of the day, no matter what it goes into, it's a software product. And that probably is the single biggest mindset change that needs to happen, where a mechanical company is no longer a mechanical company. Like Dick pointed out, it's not a car, it's your computing platform on wheels, right? Oops. So, summarizing what we really learned, selection of partners is critical, right? You somehow have to make sense out of that big maze of things and potential partners and people who will tell you that, yep, you can do all this stuff, and be able to extract from them who the right people to work are, what's the breadth of skills and experience that they bring to you. This was also talked about on the first day. I think the guys who talked about the Internet of Tomatoes, they said that you have to be able to define the problem right. So which of those value propositions that you can get from this do you want to go after? Because they're going to change everything downstream. It'll change what sensors you want, what data you want, how quickly you want the data, what your algorithms, what computation you need. This becomes very critical, not only for the solution side of things, but also for how do you know you're done? How do you say this is good? How do you go tell your boss, like, hey, I've got the product that I said I was going to give you, right? And same thing, be clear in your expected outcome, right? You can't boil the ocean. You can't eat the elephant at one time, bite at a time. Your ecosystem has to be defined. You have to know what your sandbox is, where you want to play with, and more critically, where do you not want to play? What is it that you're going to say, like, no, I'm not going to touch it right now. Right? And the biggest lesson, I don't know how many people know this Latin phrase. Festina lente means make haste slowly, rush slowly. So this is moving fast. You don't have a choice to be really slow about it. So you have to move quickly, but move quickly slowly. Meaning be sure-footed in your movement, move fast, but be sure-footed. take the time that you need to do this. So I think it's probably the most valuable lesson I learned. Because we went this, great, we got this thing, we said, wait a minute, I can't deploy it because of this. Fix that problem, something else comes up, right? So you know, plenty of smacks on the backside of my hand because I told my boss we'll have it done in 6 months, and now it's another 3 months, and then it's another 3 months, and so finally he said, like, okay, time out, I need to reset. So at the end of the day, the successful development and deployment of this smart connected system will require an enhancement of your existing capabilities, or get the capabilities that you need, and the results will have to be delivered in ways that you don't normally do. I said new and innovative, it's new and innovative because that's not what you do typically in the scene. So, and within Ingersoll Rand, we believe that this innovation on the smart connected product will be crucial in the coming years to continue to deliver on our promise to our customers, to continue to enhance the quality of life that we do with our products. So that's my pitch.